as I was saying, last week and the last 2 weeks were about segments. This week and the next couple weeks are going to be about angles. And we're going to do a lot of the same things that we did with segments, so some of this will be familiar. And we're also going to have some new terms and vocab that we're going to look at. So this is going to be all about angles. Just to give you a timeline, we're going to spend about 3 weeks talking about angles. And so this week, next week, and the week after, and then that Friday will be our next test. I'll put that in the calendar later today so that you can see what that looks like. But 3 weeks is how long we're going to spend on things. An angle is formed by two different rays with the same endpoint. So I have two, remember rays have a starting point and then go off forever in a direction. So then if I have two different rays that are coming out from the same point and then going off in different directions, they form what's called an angle. And what the angle basically measures is how far apart in direction the rays go. So if the rays go in a really close together direction, then we have a really small angle. And the farther apart the directions the rays go, the larger our angle is going to be. Right? And if they go in completely opposite directions, then we have a straight line. And we measure angles in degrees. The way we label an angle is more or less by tracing it out. So we had, in segments, we put a little bar above to say that it was a segment. When we label angles, we're going to have this little angle symbol here. And the way we name the angle is just by tracing it out. So we have angle, well, to trace out this angle, we would go through A first, and then come down to B, and then go out through C. So that's the order we're going to write our letters in. A, down to B, out through C. Or we could draw it and trace it out the other way. We can go through C, hit B, and then come out through A. And name it the other way, angle CBA. So those are the two different ways we can name our angles. One word that I want to introduce here is the vertex. So I said that if we have two rays that start at the same point and then come out in different directions, that original point that the rays go out from, so point B in this case, this point that the rays come out from, then that the angle originates from, this point is called a vertex. So the vertex is the point that the angle originates from. And when we label these angles, if we do it correctly, then the vertex should end up being in the middle. Vertex in the middle, vertex in the middle. And then I can also name an angle by its, just as a vertex, angle B. But I don't want to do it this way if I have multiple angle B's in the diagram. So for example, if I had a drawing that looks like this, here's B, and I want to call it angle B, that's fine. But then if I had something like that, and I call it angle B, well, no, not so good. Because which angle B are you talking about? Are you talking about this little angle over here? Or are you talking about this angle down here? Or are you talking about the entire angle? We don't know. Now you need to be more specific and use the 3 letters. So most of the time today, you're going to have diagrams where we're going to need to use the 3 letters to name our angle. So 3 letters, vertex in the middle. It's basically tracing out what our angle looks like. And we want to name them in these orders with the vertex in the middle, so that we can tell the difference between angle ABC and, for example, angle CAB. This is not the same angle. Angle CAB would be starting at C, going out to A being the vertex, and then going out towards B. Here's where angle CAB would be. Not the same angle. So that's why the order of the letters matters, so that we can tell apart which angle's which here. So these are the ways that we can name the angle. Vertex in the middle, so ABC or CBA. That's the same angle, just starting from the other way. Or we can name it with the vertex, as there's only one angle B in the diagram that we could be talking about. And we're feeling lazy. That's our angles, vertex, and how we name it. Now, let's talk about the angle addition postulate. Earlier, we had a segment addition postulate that said, here are my 2 lengths of the segment, 2 pieces of the segment, and I can add those pieces together and get the entire length. And we did a whole bunch of problems and examples and equations with that. Took 2 pieces of the segment, added them together to get the whole thing. Or if I knew the whole thing, I could use that to get the pieces. Well, now we have the angle addition postulate. And guess what it's going to say? It's going to say if I take the pieces of, if I take an angle and divide it into pieces, I can add the pieces together to get the whole thing. Basically the same thing. So we add the pieces of the angle together to get the whole thing. So that means that I know that if I know that angle RSP, R to S to P, would be this angle. Let's use red. R to S to P, 35 degrees. And I knew that P to S to T, angle in green here, was 27 degrees. Then I could say that the entire angle, RST, in blue, R to S out to T, the entire angle, we just take the pieces, add them together. 35 and 27 would be 62 degrees for the measure of the entire angle. So it's more or less saying the same thing that the segment addition postulate says. It's just with a different type of diagram. But it's the same idea. Add the pieces together, get the whole thing. Sure that we're doing everything right. Here we go. First example. We are told the measure of angle XYZ is 72, and we want to know XYW and ZYW. So first off, XYW is here. X, trace it out, down to Y, and out through W. So this naming of the angles also helps us be able to identify in the diagram what angle we're talking about. XYW, well, we can use that just to trace out the angle and see which angle we're talking about. That angle is 2x minus 9. And then I have ZYW here. ZYW, starting at Z, we're going to go into Y and then out through W. And that's 3x plus 6. And then we're also told that XYZ, measure of angle XYZ, is 72. And that's X to Y out to Z. So that entire angle is 72 degrees. And so what we're going to do, angle addition postulate says we can take the pieces, add them together, get the whole thing. So our pieces here, this piece is 2x minus 9, or sorry, back up. Measure of angle XYW, that's our first piece. And then we have ZYW, the 3x plus 6 there is ZYW, that's our other piece. And then the entire thing is XYZ. This is the building blocks that we're going to use for our equation. And by the way, I have this little M that I've been writing, and you'll notice that we have these little M's up here. That's used to stand for measure. That's used to say we're talking about the measurement of the angle instead of just identifying the angle. That's all that means. So when we want to say a measurement, we usually just write out a little M there. So that's the building blocks. Take the pieces, add them together, and they should equal the entire thing. So the pieces, XYW, that piece is 2x minus 9. Plus our other piece here is 3x plus 6. That's ZYW. Equals the measure of the entire thing, which is 72. Now, don't forget, we don't add or subtract anything to both sides yet. The right side's going to stay 72 for now because we need to put the terms together on the left side before we start moving things around. So let's put our like terms together. I got a 2x here and a 3x here. Put those together, I get 5x. I got a minus 9 here and a plus 6 here. Minus 9 plus 6 is going to be minus 3. And now we can start moving things. Get rid of subtraction by adding 3 to both sides. And we get a 5x on the left equals, on the right side, 72 and 3 is 75. So we divide by 5 on both sides to get rid of the multiplying. And we get x to be 75 divided by 5 is going to be 15. So we get 15 for x. Now we're going to plug that in to get the other measurements that we need. The problem asked for the measure of angle XYW and the measure of angle ZYW. In other words, it's asking us to plug in the pieces and make sure that they add together to get the whole thing. XYW. So we're going to take 15, put it in for x. Take 15, put it in for x. So we've got XYW is 2x minus 9. So we're going to plug in 15. 2 times x is 15 minus 9. And we get 30 minus 9. 2 times 15 is 30. Minus 9 is 21 degrees. We label angles in degrees. For ZYW is the 3x plus 6. So the 3x plus 6, plug in 15. 3 times x is 15 plus 6. And then we have 3 times 15 is 45, and 6 is going to be 51 degrees. And, moment of truth, if we did it right, the pieces should add together to get the whole thing. 21 and 51, add them together. Oh, it's 72. We did it right. Questions on that problem? Take pieces, add them together, we get the whole thing. Let's jump ahead here, because this one I'm going to ask you to do on your own, just so you know. But let's jump ahead to this one, because this one's a little bit harder. Because no picture. We got to make the picture and the diagram ourselves. So a tip that I was giving for people who were having trouble with the diagram and drawing the diagram in the last chapter is we were told something like B is between A and C. And what I said to do was don't start by drawing B. Start by drawing A and C, and then put B in between it. So I'm going to tell you something similar here. It's going to tell you that P is in the interior. You don't need to write this down because this is in the directions. It should say something like P is in the interior of angle ABC. So I'm going to tell you the exact same thing that I said with the segments. Don't start by drawing P. Start by drawing angle ABC and then put P inside of it. So let's do that. I'm going to make my angle a little bigger this time. So angle ABC, which point is the vertex? When we named an angle, where did we say the vertex went? It's in the middle. So that means B has to be the vertex where the angle comes together. This should be B. And then we'll put A over here and C over here. Now we have angle ABC. Now let's put point P somewhere in the interior. So inside of the angle, somewhere around here, here's point P. And now we'll start labeling. Measure of angle ABC, the entire thing. The entire angle is 13x plus 22. Then our piece here, measure of angle ABP. A to B out to P. Remember, if you see the name of the angle, then that'll let you just trace it out. A to B out to P, right there, is 7x plus 1. And then PBC, That's P down to B out through C is 93 degrees. So now I can set up my equation. My equation should still be take your pieces, add them together, get the whole thing. The whole thing, the entire angle of ABC this time is 13x plus 22. This is important. I know it's nice and comfortable to put the number on the right side a lot. It's what we do in a lot of the equations, not here. Because the number, the 93, is one of the pieces. So it goes on the left side. My pieces are the 7x plus 1 and the 93. Your equation should be able to point back to the diagram and say, here's where I got it from. Why did I add these together? Because the two angles should add together, these pieces should add together to get the whole thing. And you should be able to point to me in the diagram and explain why you got the equation you got. Now let's solve it. Again, before I move anything else around, we're going to put together our terms on the same side. 7x here. I got a plus 1 and a plus 93. That's going to be plus 94. And over here, I just have the 13x plus 22. Now I can start moving things around. We're going to subtract 7x from both sides. Seven x's cancel here, and I just have a 94. $13x minus 7x, that's going to be 6x plus 22. Now we can subtract. Now that we have everything with x on the same side, 94 and 22 is 72. Divide by 6 to get rid of the multiplying, and we get 12 for x. So that should be our answer for x. That's going to be 12. Now we're going to take this and plug it into the pieces to make sure that what we're getting out is right. Measure of angle ABP. This is my red piece. 7x plus 1, so we're going to take 12 that we got for x and plug it in for x. 7 times x is 12 plus 1. 7 times 12 is 84, and 1 is 85 degrees. And hopefully you should be able to tell me at this point what ABC comes out to be. Because if we did it right, then it should be the pieces added together. I have this piece here is 85, and this piece here is 93. If I add those together, I should get the whole thing. Let's see. 13x plus 22, so we have 13 times x is 12, we said, plus 22. 13 times 12, well, 12 times 12 is 144, excuse me. And another 12 is going to be 156. So this is 156 plus 22 is 178 degrees. And then a shocking twist, If I take 85 and add the 93, the pieces, I add them together, oh, I'd get 178. I'd get the whole thing. So those pieces added together gives us the entire thing. Plug back in. The angle it asked us for was ABC, so this would be our final answer, 178 degrees. Questions on that? So in the diagram, make sure you're careful with tracing out your angle and labeling the things that it tells you. This one I want you to try on your own. And in a moment, I will show you what you should get for the answer. And it should go into the other angles. Plug it back in just like we did on the last problems. Plug them back in to get the measures of the angles.